This is no harder than the last one we just went over. The only thing I threw at you that was any different is that now I'm concerned with 2 genes rather than just 1 gene in your cow. So if you're a cow farmer, is there really just 1 gene that makes your cows valuable? There's probably a whole mess of genes that cow farmers actually look for. There's all kinds of genes that dictate how big the cow is going to get and how likely it is to fight off infection and stuff. You don't want sick cows if you're a cow farmer. Believe it or not, something that they actually breed into livestock animals is friendliness. And they call it being docile, but you don't want farm animals that fight you. You want them to go where you want all the cows to move into this field. You want them just to go. You want to breed out behaviors that make them want to go out on their own and stuff. And you can breed that stuff out. You can actually pay attention to their genetics and control their behavior. And we've talked about how genetics largely controls behaviors. So this is not an unrealistic question. This particular farmer wants fat, friendly cow babies. Which makes sense. If you're a cow farmer, you don't want mean cows. You want friendly cows. And you also want them to be large because that makes more hamburger, and more hamburger makes you more profit. So, the first thing I would do when approaching these problems, watch. And I would recommend you do this tomorrow. It will help you. For fat gene, fat is the recessive allele. I would underline that. And then for the friendly gene, friendly is the dominant allele. I know I'm going to need that information again later. So I'd underline it right in the setup of the problem. Then I know I also am going to need the cow's genotypes, and there's the bull's genotypes. Right? So I'd underline and circle stuff in the setup of the problem so that I know where to refer back to information. By the way, once again, cows are girls and bulls are boys. And it's very helpful when you're trying to make baby cows if you got one of each. Okay. Now, number 3. What are the chances of cow and bull above having fat, friendly offspring? How many different genes am I looking at? 2. So how many Punnett squares should I have? 2. So that's the first thing I would do is draw 2 of my little kindergarten house windows. I'll come over here. I'll draw another one. As these problems become more complicated, which they will here, it's going to be in your best interest to keep everything labeled. So like for me, for example, I'm going to label this one my fat square, and this one over here is keeping track of friendly. So I'd label them both so that I don't lose track. Okay. Next little trick here. Now I want to fill in the cows and the bulls. So in this one over here on the left, I'm going to put the guy's alleles on the top. And over here, I'm going to put guy alleles on the top. I'm just making myself little notes here so I don't lose track of anything. I'll put the girls over here and over there. Okay. Now when I go to fill in my genotypes on my Punnett squares, because that's the next thing I do is I fill in the tops and the sides with the cows and bulls genotypes. So first, for the fat gene, what does my cow have for the fat gene? What does the cow have for the fat gene? She's homozygous recessive. So what would that be? What would that look like? 2 little f's. She's homozygous recessive. How about the bull? Heterozygous. He was heterozygous for the fat gene. So over here, what do I put? Yep, I put big F here. Half the time when he goes to make a sperm cell, he's going to put big F. Oh, wait a minute. I did this wrong. Sorry. I did everything wrong.
You just told us cows.
I told you. I tried to make my cow into a girl. Whoops-a-daisies. Okay, watch. Let's try this again. The cow is homozygous recessive, so little f over here. Yeah. And the bull is heterozygous? Yes. So he's big F, little f. There we go. Yeah. And then friendliness goes over here. When I go to do the friendliness alleles, do I want to use F again? No, don't use the same letter for 2 different genes. It'll make life confusing. So instead, I'll pick the second letter And let's see. For the friendly genotype, I had homozygous dominant for the cow. So she is really friendly. Okay. And we had heterozygous for the bull. So what does that mean he's got? Big R and a little r. Now I can go through and do the Punnett squares. When I go to do the Punnett squares, the cow could have a sperm cell that contains the big F version or the little f version. So I'll fill in his first. They could go there, or there, or there, or there. And the bull, what is, or the, no, I'm sorry. The cow is always given what? This cow is always giving what version? She's always giving little f's, right? No matter which egg cell she makes, it's always going to contain a little f version of the gene. So she's going to contribute little f, little f, little f, or a little f. Over here, we're going to end up with this. Make sense? Now I got to interpret my Punnett squares. I'm not quite done yet. What are the chances of the bull and the cow above having fat, friendly offspring? So to be fat, what would I need? Again, I go back up here. Fat is the recessive allele. So I want fat cows. Is this one fat? Oh, because it's recessive, and the dominant would cover the recessive. So in this case, the skinny is covering the fat, and this one is the skinny cow. How about this one? Skinny. That one? Fat. And that one? Fat. So what's the odds there? Yeah, 2 out of 4. And if you wanted to make that into percentages, you could. Or you can just leave it as a fraction. That's fine. I'm going to take that 2 out of 4, and I'm going to multiply it by my odds of being friendly. I go back up here. Friendly is dominant. So is that a friendly cow? Yeah. Is that a friendly cow? Yeah. Is that a friendly cow? Yeah, because the dominant covers the recessive, and it's dominant to be friendly. So that's a friendly cow, and that's a friendly cow. So how many out of 4 is that? 4 out of 4. So I go 4 out of 4. Now, you can't see that. You know, you got to show me what you're going to do on the bottom to figure out the odds of both.
So wait, if you're breeding cows, you don't want to breed heterozygous because eventually it's dose.
2 by 4 is 8. 4 by 4 is 16. We get 8 out of 16 are going to be fat and friendly. Okay, that reduce. If you want to reduce the fraction, I don't even care if you reduce the fraction. If you gave me that, I would be close enough.
50-50.
Okay, but if you can reduce fractions, it's 1/2 chance of fat friendly. Yeah, you can almost read that. There you go. That's how I figured it out, though. You got to multiply the odds of each event happening together. Are we good with that one? The last question said, what are the chances of the cow and the bull above having offspring cows that are heterozygous for both traits? It's not using the same Punnett squares, but I'm just asking you to figure out a different outcome. So let's see. Is that one heterozygous?
Yes.
Yeah. Is that one heterozygous?
No.
That one is?
Yes.
That one's not? So that's 2 out of 4. So down here, 2 out of 4 in the fat are heterozygous. How about for the friendly one? Yeah. Is that one heterozygous? Is that one? Yeah, that one? That one? Yeah, so that's 2 out of 4 too. And again, to multiply fractions, this is something you should have picked up a long time ago, but just as a review, to multiply fractions, I go 2 by 2. 2 by 2 equals 4, and 4 by 4 equals 16. I get 4 out of 16, which reduces to 1/4 chance.
I can't see. Is that bottle in the way? Is that? Oh, I see. Bottle.
Here. We good?
Do we want to pick these back up so we have them?
What was grand? Orbital.
Okay, one moment. Is everyone understanding what they got wrong if they got things wrong?
Yep.
I do.
Okay.
Does anybody have any questions?
Thanks for the
They
song,
need it
Chris.
repeated.
Now it's time. I will remind you that tomorrow your quiz is going to look very, very similar to this.